API Security Best Practices for .NET Applications, a developer's checklist. API Security Best Practices for .NET Applications, a developer's checklist. That's what we're tackling today. If you've been wondering about API development services, stick around. Let's talk about why API security deserves its own checklist in .NET. The attack surface of a modern .NET API is wider than most teams admit. You have JWT validation, model binding, serialization, EF core query construction, third-party NuGet packages, and the infrastructure layer surrounding it all. OWASP's API Security Top 10 lists broken object-level authorization, broken authentication, and unrestricted resource consumption as the top 3 risks. Each one has a specific .NET fix, and skipping any of them is the difference between a passing pen test and a Monday morning incident call. IBM's 2024 Cost of a Data Breach report puts the average breach at $4.88 million, with API-related incidents trending higher because of the volume of records exposed per event. For regulated sectors, healthcare, banking, logistics, that number climbs further once HIPAA, PCI-DSS, or SOX penalties enter the picture. The teams we work with through our Azure consulting services typically discover 3 to 5 critical API issues during their first security review. This is not a theoretical guide. Every item below maps to a concrete .NET 8 or .NET 9 implementation detail, a NuGet package, a middleware configuration, or an Azure service. If you are evaluating a Microsoft Azure consulting company or running an internal review, use this as the baseline. Let's talk about now. Authentication. Lock the front door first. Most API breaches start with weak or missing authentication. ASP.NET Core gives you the primitives, but defaults are not enough. When you call in, validate every claim that matters: issuer, audience, lifetime, and signing key. Setting is non-negotiable. Use to pin the expected issuer to your Azure AD tenant or identity server instance. Never accept tokens from any issuer. Rolling your own token system is one of the fastest ways to introduce vulnerabilities. Microsoft Entra ID handles token issuance, rotation, and revocation properly. Our Azure migration partner engagements almost always include moving customers off bespoke auth onto Entra ID with the package. Next up, authorization. Authentication is not enough. Knowing who the caller is does not tell you what they can do. Broken object-level authorization is the #1 API risk for a reason. Do not check roles at the controller level and call it done. Every endpoint that returns or modifies a specific resource needs an explicit check that the caller owns or has rights to that resource. ASP.NET Cores with custom classes is built exactly for this. Roles are coarse. Policies let you compose claims, scopes, and resource ownership into reusable rules. Define them once in and apply them with. This pattern scales when you move from a monolith to microservices, which is something our Azure DevOps consulting services teams handle frequently. Let's talk about now, input validation and model binding safety. Trust nothing that comes in over the wire. Even authenticated clients can send malformed or malicious payloads. Use, and on every DTO. For complex rules, Fluent Validation gives you composable validators with better error messages. Return with a clear problem details response so clients know what to fix. Never bind directly to your EF core entities. Always use DTOs that expose only the fields a client is allowed to set. Otherwise, an attacker can include in a JSON body and your model binder will happily set it. Let's talk about now, rate limiting and resource protection. Unrestricted resource consumption is API Security Top 10 number 4. .NET 8 finally shipped first-class rate limiting middleware, so there is no excuse to skip it. It supports fixed window, sliding window, token bucket, and concurrency limiters. For most public APIs, a sliding window per authenticated user plus a stricter fixed window per IP for unauthenticated routes is a sensible default. Kestrel's defaults to 30 megabytes. For most JSON APIs, that is far too generous. Drop it to what your largest legitimate payload actually needs. Combine with middleware in .NET 8 Plus to kill long-running requests that could exhaust thread pool resources. Let's talk about now, transport and data protection. Everything above assumes the bytes on the wire are confidential and untampered. That assumption needs enforcement. and are one-liners. There is no reason not to use them in production. Set HSTS max age to at least 1 year and include subdomains once you have validated all of them. Serve TLS. Configure Kestrel to reject older TLS versions. Azure App Service and Azure Front Door let you enforce this at the platform layer, which is one less thing to misconfigure in code. Next up, dependency and supply chain hygiene. Your API is only as secure as the weakest NuGet package you ship. Make this a required check in your Azure DevOps Consulting Services pipeline or GitHub Actions workflow. Fail the build on any high or critical vulnerability. Pair it with Dependabot or Renovate to get automated PRs for updates. Floating versions like mean a transitive dependency update can change your binary surface overnight. Use with and commit the log file. Now, moving on to logging, monitoring, and incident response. You cannot defend what you cannot see. Insufficient logging shows up in nearly every breach postmortem. Use Serilog or the built-in with structured properties. Log authentication failures, authorization denials, rate limit hits, and any exception that surfaces from your data layer. Ship logs to Azure Monitor or Log Analytics for centralized querying. This is the easiest rule to break. Use a Serilog destructuring policy or a custom for application insights to scrub fields like and before they leave the process. Now, securing the deployment pipeline. The API is only secure if the path from commit to production is secure too. This is where Azure Cloud Migration Services projects often uncover the biggest gaps. Azure Managed Identities eliminate the need to store database credentials, storage keys, or service principal secrets in app settings. The package handles token acquisition transparently. If you ship containers, run Trivy or Microsoft Defender for containers on every build. For Bicep or Terraform, use Azure to catch misconfigured network security groups and public storage accounts before they reach Azure. Let's talk about next up, compliance considerations for regulated industries. Generic security controls are necessary but not sufficient when HIPAA, PCI DSS, SOX, or GDPR apply. For a healthcare client, every control above maps to a specific HIPAA security rule safeguard. For PCI DSS, Requirement 6.5 explicitly calls out injection flaws, broken authentication, and insecure cryptographic storage. Document the mapping so auditors do not have to guess. For banking and healthcare APIs, automated deployment to production without a human approval gate is a compliance risk. Configure Azure DevOps environments with required approvers, or use GitHub Actions environment protection rules. This is the governance model we apply across our Power Automate consulting and Power Platform governance engagements. Let's talk about now how this checklist fits into a broader modernization. Securing an API in isolation is useful. Securing it as part of a coordinated platform strategy is better. If you are also working through Azure App Modernization, an Azure Infrastructure Assessment, or an Azure Security Assessment, the controls above should be baked into your reference architecture, not retrofitted per service. Many of our clients combine this API security work with a broader .NET application modernization roadmap and an Azure Landing Zone implementation. Teams running on older runtimes often pair it with our legacy .NET framework to .NET August 9th migration checklist. For organizations on Azure DevOps, the Azure DevOps versus GitHub Actions comparison helps decide where the security gates should live. And if PCI DSS is in scope, our guide on building PCI DSS compliant apps on Azure covers the compensating controls. Let's talk about next up, conclusion. API security in .NET is not a single feature you turn on. It is a checklist you run on every endpoint, every release, and every dependency update. The controls above, strong authentication, resource-level authorization, strict input validation, rate limiting, encrypted transport, dependency scanning, structured logging, and governed deployment, are the minimum bar for any production .NET API in 2026. If your team is short on capacity to implement them, our API development services and Azure Consulting Services can run a security assessment and ship the fixes within a single sprint. The longer you wait, the more expensive the eventual incident becomes. Start with authentication and authorization this week, and work down the list from there. Microsoft's official ASP.NET Core Security documentation is a useful companion reference as you go.